Welcome, I'm Carl Tate. We'll be discussing three types of plate boundaries. Our starting point for classifying plate boundaries is to consider the relative motion that occurs between two plates. Is it convergent, divergent, or lateral, as in side by side? It's not obvious from looking at this what the relative motion between two plates is, but one way to look at it is to consider a plate like North America, which isn't moving very fast, and a plate like the Pacific, which is moving to the northwest. And along this boundary, for example, things are moving side by side. Pacific moves to the northwest, parallel to the San Andreas boundary. Whereas along the Aleutian-Alaska boundary, you can see that the Pacific is converging, related to subduction. Similarly, in this area, you can see both plates, Nazca and Pacific, that are diverging away from the spreading ridge. So here's our table of plate boundaries, and you can see that instead of 3, there's actually 5 rows where 2 of them have been split into 2 categories. So we'll be looking at the plate tectonic setting, the relative motion, which would be divergent for the first, convergent for the second, and then lateral for the third. Global examples, Alaska region examples, and then the type of crust of the 2 plates at the boundary. Is it ocean and ocean, continent, continent, and so on? These 2-letter abbreviations show the 2 plates on either side of the boundary. And this will be our starting point for looking at these boundaries, the bathymetry and topography of the world with the plate boundaries superimposed. So let's start with seafloor spreading. The example here shown for the Mid-Atlantic Ridge running all the way down here, just showing the star in one particular spot between North America and Eurasian plate. The other example shown here in blue, the Eastern Pacific, where we have the spreading between Pacific plate and Nazca. So those are 2 examples of plate boundaries of spreading ridges. If we look in the Alaska region, we have the Juan de Fuca Ridge along here between Pacific and Juan de Fuca, where the Pacific plate moves up to the northwest and Juan de Fuca goes to the east and subducts at the Cascadia subduction zone. This would be a divergent motion across this boundary, and that would be ocean crust being formed. You can also have divergent boundaries between continental crusts, and the famous one would be the Red Sea, a divergent plate boundary of rifting between 2 continental crusts, Arabian plate and the African plate shown here. There's no examples of this in Alaska region. Next is subduction, and subduction occurs all around this western margin of the Pacific as an example, eastern margin of South America. The 2 highlighted here are northern Japan, Pacific subducting under the Okhotsk plate, and also here's an example of the Cocos plate subducting under the North American plate along Mexico. And the type of crust that would be at these boundaries would be ocean or ocean continent. For example, where the Pacific plate subducts under southern Alaska, that's a Pacific oceanic plate under continental crust. So in the Alaska region, we have clearly subduction. We have 2. One is the Cascadia subduction zone, and the other is the Aleutian-Alaska subduction zone. And both of these would be examples of ocean continent at the boundary. We now look at another convergent boundary, and this one collision between India and Eurasian plate. So we see these are 2 continents colliding with each other, and this is an example of continent-continent collision. In the Alaska region, We also have this occurring. This is a collisional zone between Pacific and North America, where the portion of the Pacific plate here is continental crust colliding with the continent of North America. And lastly, we have strike slip or transform faults with lateral motion. One example would be the San Andreas Fault between Pacific North America. This is right lateral motion, where if you stand and look at the plate opposite you, it moves to the right, whether you're standing from North America looking out to Pacific or standing on Pacific looking at North America, the relative motion is right lateral. And in Alaska, the northern version of that would be the Queen Charlotte and Fairweather fault system, also right lateral. So as we discussed earlier with how many plates, the exact number of plates does not matter as much as understanding what defines a plate. And similarly, the exact number of the types of plate boundaries is not as important as understanding what characterizes the contact between the two plates. So what is the crust, oceanic or continental on each side? What is the relative motion between the two plates? Just to give an example, we saw earlier, Peter Bird classified 7 types of plate boundaries everywhere in the world, as shown next. So he had in this, for each of the figures, he had these 7 different types of boundaries, but we could lump these together for ourselves and group in the convergent boundaries based on these 3 and the divergent boundaries based on these 3. So this is just to show there's choices to be made and what level of detail you want to look at. But for us, this would be the big subduction boundary, this blue one, which is a common one we've been discussing. Takeaway topics: 3 types of plate boundaries are divergent, convergent, and lateral. Divergent boundaries occur at seafloor spreading ridges. Convergent boundaries occur in subduction and collisional settings. And lateral boundaries are strike slip faults where 2 plates slide past each other. In the Alaska region, we have divergent spreading of the Juan de Fuca Ridge offshore of Pacific Northwest. We have convergent subduction boundary, the Aleutian subduction zone. We have convergent collisional zone in the form along the St. Elias Mountains, the highest coastal mountains in the world. And then we have lateral strike slip motion along the Queen Charlotte and Fairweather right lateral strike slip fault.